So we have been working on motion in two dimensions. R, V, and A are all related in this manner. R is xi hat plus yj hat. Those are functions of time. So the instantaneous velocity and acceleration come out in a very straightforward way by taking the first derivative and the second derivative respectively. Notice you can also take dv dt to get A. The first derivative of V will give you A, which is the second derivative of R. If you want, though, don't turn the camera. I learned that already. If you want the averages, it's displacement over time and velocity change over time, where delta R is the displacement. So the problem we worked is on page 84, number 11. We get R as a function of t that looks like this. It's only got an I hat and a j hat. He wants to know what R, V, and the acceleration are all after 2 seconds. So to get R, you plug in directly. Put in 2 everywhere you see t. The numbers work out to be 6i hat minus 106j hat. The velocity requires us to take a derivative of the position as a function of time. So we have here 2t cubed minus 5t. The first derivative of the I hat piece will give 6t squared minus 5. And the second component, the j hat component, will give 0. The derivative of a constant is 0, minus 28t cubed. And that's what you see here. And I put 2 in directly, and the numbers work out to be 19i hat minus 224j hat. The acceleration requires the second derivative of the position, or we could just take the first derivative of the velocity. When I take the first derivative of the velocity, that is 6t squared ddt, giving me 12t, and the 5 doesn't contribute, it's a constant. Minus 3 comes down to give me 3 times 28, which is 84, t squared. Did I make a mistake there? I did not. So you plug in 2 everywhere you have a t here. 12 times 2 is 24. Minus 84 times 2 squared is 84 times 4, which is 336 j hat. The last part of that question is what's the angle between the x-axis, which is I hat, and the tangent to the position curve at t equal 2 seconds. If you have something moving like this around, the tangent to the curve as a position as a function of time is just the velocity. You know that, okay? You know that from everyday life. So we take v dot I hat using our dot product formula, which is v magnitude times the magnitude of I hat, which is how much, class?
1.
1, thank you. Thanks to you all for contributing. V times 1 times the cosine of the angle. I dot 19 I hat minus 224 j hat. I find the magnitude of v of the other side, and I solve for cosine theta, and the answer is 85 degrees.